Here in Lecture 10, we're going to take a look at the issue of who owns pointers to dynamically allocated objects, and therefore who is responsible, or which part of your code is responsible for properly deleting these dynamically allocated objects. I'd like to review what we looked at back in Lecture 5 about the classes that we were using for arithmetic expressions. We had term, constant, binary op, plus, and term was our base class, which has these two pure virtual functions, toString and toValue, which therefore need to be overridden in the higher level classes. Constant was one of the higher level classes derived from term that has specific implementations of toString and toValue. Binary op is still an abstract class. It is a base class used for things like plus, times, minus, divides. And what binary op does is to take the two operands, the left and right operands, and keep the pointers to those things in these left and right pointers to terms, data members within the binary op object. Now, at this point, we had the binary op object become the owner of these pointers, so that when the binary op object was destroyed, the binary op operator destructor did the deletes of the left and right side. And by having the binary op be the owner of these pointers, this enabled us to build an arithmetic expression using binary op operators to combine together the various terms in our expression, so that we only had to do a delete of the pointer to the topmost binary op. In this case, we did a delete of the second plus operator, and that took care recursively of deleting the other plus operator as well as the three constant objects in the expression. This is fine, but we discovered that we had trouble when we tried to add one term twice. That is, we defined a variable class in the homework, and if we tried to make use of the same variable two times, then when we deleted the top level term in our arithmetic expression, that ends up causing the variable to be deleted twice. The first time is fine, but the second time causes a crash. So this gets us to a very common problem, and gets us to an important question, which is, in your application, who or what owns the pointers to the dynamically allocated objects, and therefore who or what is responsible for deleting those objects when you're no longer using them. One solution is to make the allocator of objects the owner of the objects and responsible for deleting those objects. So, in other words, if you use new, then you use delete. In our case, that would mean that the developer of the main function, who is allocating these terms, constants, variables, and various binary ops, is going to be responsible for deleting each of these things at the end of the application. In this case, we're going to want to modify our binary op class so that the binary op class does contain pointers to the left and right terms around the binary operator symbol, but is not considered to be the owner of those pointers. And so we modify our destructor so that the destructor is no longer responsible for doing deletes of these pointers. Our application then looks like this on slide 5 and slide 6. We're creating a very simple arithmetic expression here involving 5 terms, 2 constants, 1 variable, 1 plus, and 1 minus. And we're then displaying the string representation and the value of that arithmetic expression. And because in main we were the ones who used new, we take responsibility for using delete to delete each one of those terms after we're done using them. Now, one advantage here is that if you use any term multiple times, for example, you could create an expression that uses the variable v1 multiple times, or that uses the constant c2 multiple times, and this is fine. The disadvantage is that it looks kind of nasty, and it relies on the application developer to do the right thing and do exactly one delete for each allocated term. This somewhat defeats the purpose of developing a class in the first place. One of the purposes of developing a class, such as our hierarchy of terms here, is to make life easy for application developers and safe and simple. And here we're definitely not doing that. So to hide some of this mess from the application developer, another approach would be to make the base class be the owner of all of the objects that belong to the various derived classes. Then what you'll need to have is some kind of clear static member function that belongs to the base class as a whole that the application developer can call to clean up all of the allocated objects when the application is no longer using those objects. If we go with this approach, we're still going to need to make the same change in the binary op class. That is, we're going to need to make the binary op class know about the addresses of the left and right terms, but not be the owner of those pointers, so that the destructor is modified so that it does not do delete of left and right. All this deleting is pushed down a level into the term class, and in this particular example, what we're doing is creating a private data member in the term class. STP is a set of term pointers. All right, notice that we're using the set container class here. We're setting STP up as a static data member so that it will exist for the term class as a whole, even if no term objects currently exist. We're modifying the constructor for the term class so that each time a term is created, the pointer to the current term is inserted into our set of term pointers. Okay, so if we create a constant is a kind of term, and so the address of the constant will be inserted into this set of term pointers in the term class. Likewise, if we create a variable, or if we create a plus, or if we create a divides, each of these terms will have its address stored in this set of term pointers in the base class. In order that the application developer can clear all the terms, we're adding a static member function named clear, which will traverse through all of the term pointers in the set and delete each one. So here on slide 10 is what we need to add in the code file for the term class to support the changes that we've made in the definition of the term class in the header. We need to define that STP is a member of the term class and it is a set of pointers to terms. We also need to define what the clear static member function does. It's using an iterator to step through each of the values in the set of term pointers, the STP set, and it's invoking delete on each of those pointed to term objects. Now, once we've deleted the dynamically allocated storage for each one of those term objects, we also need to clear the set itself. So in this last statement, we're calling the clear member function of the set class so that the set is now reduced to containing 0 elements.